Hello everybody, my name is Dr. Naveen Rawat and this is the first lecture on mechanics course PH3106. Part that we are discussing today is just introductory. Okay, so mechanics has a very big history, right? So starting from 1600 until now, you have this 400 years of history, which is going to be compacted and presented to you in a certain manner. So a lot of things might be included, some of the things might be left out. In the introductory lecture, I had talked a little bit about the different fields of physics and how they evolved over time. And the field of mechanics, which comes under classical physics, is basically the foundation of your pure and applied physics. Okay, and essentially the Newton's laws and statistical mechanics that we'll be using goes a long way in dealing with a lot of systems that are present around us, okay, in the macroscopic world, right? So when we want to look at how particles are moving in a solid, how the waves are getting generated like sound waves, or how the light interacting with a solid. So we'll be using all these laws in it. Okay, in mechanics, what we want to focus on is how the objects are moving. There are some forces that will be acting on an object, and when there will be force acting on an object, it will cause the object to move. Some point of time we are trying to do some prediction on their motion, that if you understand their motion, then we can predict after 10 minutes or after 1 hour where the object will be, what kind of motion it will be doing. So all those things we can do. Okay, so for that purpose we need some laws and we need some basic initial starting parameters. There is some gravitational force acting on the object, or there is some uh, electromagnetic force acting on these objects. So you should have some basic understanding of the forces. Okay, all the four basic type of forces that we have, right, the mechanics can be applied to all of them. Okay, so at some point of time we'll be talking a little bit about some classification of forces pertaining to mechanics, but essentially the whole idea is, if there is some force is present on an object and the object is moving, how will it move is what we are trying to determine using mechanics. A definition that you can think of classical mechanics is that it is a science of these bodies that are at rest or they are in motion. Again, just to remind you, there can be forces acting on an object and it can still be in rest. Okay, and there can be forces acting on an object and it can cause the object to move. So both of these criteria might be there. Where the force is coming from and what are the sources, whether it is from a galaxy far away or some other object, or that is very little of our concern. So of course a lot of development, as you know, happened from the time of Galilei. He is known as the father of modern physics, and he established the idea that you have to do experiments, collect data to understand the motion of the objects. And earlier during their times, they were observing all these different objects in the sky. They were moving and they were trying to predict their motion. Okay, and from that basic observation that they were doing, they realized a lot of new things about the universe around us, right? It was discovered later on that the earth is not the center of the universe, and then they realized that is not the case. It is actually the sun, and the earth is moving around the sun and other planets are moving around the sun. It's quite interesting that the year Newton was born is the year Galileo died, and then Newton completely changed the field of mechanics when he presented his laws of motion. Okay, you can divide the mechanics into two parts. Okay, you can either be dealing with kinematics or you can be dealing with dynamics. Okay, and in kinematics, basically what we are doing is we are looking at the motion of the objects, and we are not concerned with the forces. And if you remember your kinematics equations, there was no force term in there. Okay, so there was only position, there was time, there was acceleration, but there was no mention of what the force is, and we didn't need that. Okay, but now in this course you will be dealing with a little bit with the dynamics as well. So we'll be looking at some forces, how the forces change the motion of an object, and we'll be looking at the Newton laws a little bit in detail. Okay, the mechanics, it is trying to provide a description of the dynamics of the particles that are following some set of physical laws. A body will remain at rest or a body will remain in uniform motion unless it is acted upon by a force. Okay, so it is also known as the law of inertia. Okay, so essentially what we are saying is, if it is moving with a constant motion, right, that means there is no acceleration. Okay, so that means there is no force acting on it. Okay, so if an object has to change its motion from a straight line, for example, if something is going in a circular path, that means it has to, at every point around the circle, it has to have some acceleration acting upon it. Okay, so if you draw this as the direction of its velocity, you can see that at every point the direction will be different. So it can have a constant speed. However, to perform this circular motion, this object needs an acceleration. Okay, so that acceleration could be centripetal acceleration, or it could be coming from somewhere else, but that is a basic understanding of what is going on. Okay, we are aware of the systems around us, the sun, the moon, the earth, and all these things, they follow this circular path. So there is this force present in nature that is causing this to happen. Okay, the statement for the second law says that a body that is acted upon by a force, what will happen to the body? So it will move in such a manner that the time rate of change of the momentum equals the net force acting on the body. Okay, so in mathematical terms, what we say is the force which is here, right, and this force is not just any force, it is the net force. So we should write net here. So that is the net force. That means that is the sum of all the forces acting on a particular object. Okay, it is nothing but it is the change of this momentum with respect to time. Okay, and you have the situation that we know linear momentum is given by mass times velocity. So if we rewrite this equation, we get the net force will be d by dt of m times v, and if you consider that the mass is constant, then you can take it out of the equation, and then you get m dv by dt, and that is essentially your mass times acceleration. Okay, so F is equal to ma. So that is the common form it is represented as. Okay, if the net force is 0, that means if the object has some mass, then obviously the acceleration has to be 0. Okay, so if acceleration has to be 0, that means that the velocity is not changing. So again, very close to the first law. Okay, so if there is no change in velocity, then this term is 0 and the net force is 0. Okay, and again, remember, it is a net force. There might be forces acting. For example, there might be an object like this, and there might be a force acting in this direction, and then there might be a force acting in the opposite direction. So now there are two forces acting. If these two forces are the same and this line of action is linear along a straight line, then this object will not move. And if this object is not moving, then there is no velocity. So again, this term is 0. However, there is forces acting on this object, but the net force is 0. Okay, so similarly, we have the third law, which is commonly known as the law of action and reaction, and it says that if there are two bodies, they exert forces on each other, force will be equal in magnitude and opposite in direction. Okay, so basically you're saying you're standing like this, there is a desk here that you're trying to move, so you're applying a force in this direction, that is F1. So the desk is applying some force in the opposite direction, and because the direction is opposite, so if you look at if you calculate the magnitude will be the same, but when we write in the vector form, we have to put a negative sign saying that the direction is different. So like we were discussing the third law, there is an alternate way to express it, and sometimes it might be useful. And we can say that if there are two bodies and they are in an isolated system, that means there are no something external acting on this body, though there are no external forces acting on this body, then their accelerations are always in the opposite direction. Okay, and we can also say that the ratio of the magnitude of the acceleration is constant, and that ratio of the magnitude will be equal to the inverse ratio of the masses of the two bodies. So this observation might be useful for you later on when you're trying to solve some problems. Like I had just shown, if you have two forces, F1 and F2, and they are acting in opposite direction because of the reaction, so then there will be a negative sign here. right? And we said because of the second law, force is nothing but the change of momentum. So you have F1 would be d by dt of this P1, which is, we should properly write it as a vector. So I'm going to put some vector signs here. Similarly, it will be equal to minus of the d by dt of the momentum of the second object. Okay, and we know that momentum is nothing but m times v. So for P1, we will have m1 times v1, and we are saying that m1 is constant, so it will come out of the equation, and you will left with dv1 by dt. And then on the right hand side, you have again m2 is constant, so we are considering mass is not changing, and then you have a minus sign, and then you have dv2 by dt, which is inside, that is coming from this second momentum. Okay, and this is nothing but the acceleration of the first particle. So you have m1a1 on the left hand side, and on the right hand side you have m2 times minus a2, because this is the derivative with respect to v2. Okay, so again, so if you isolate the masses on one side, and so you can divide by m1. Okay, so you get m2 by m1 on the right hand side, so that you have m2 by m1 on one side, and then if you divide by a2, so you will get a1 by a2 on one side, and that is what you are getting here expression. Okay, so the ratio of the masses of the two objects, right, is equal to the inverse ratio of the acceleration. Okay, and there is a minus sign. Okay, so this is another way of representing the same second and third law. So just by knowing the mass of one object and looking at the motion of the two objects, you can figure out the mass of the second object, right? So that is one of the applications you can do, right? So this is basically what you would do when you're doing an experiment. Okay, anything that you are discussing in physics in terms of whether you're talking about length, you're talking about mass, whether position, which is one of the main fundamental things that is required to describe a particle, you have to use a reference frame, right? So because if I make a statement in physics that an object is moving with a velocity of 20 meters per second, okay? So that is an incomplete statement, because you have to say 20 meters per second with respect to what, right? So if I say the same statement and I say that an object is moving uh, at a speed of 20 meters per second with respect to a car that is moving, so, and suppose the car is moving at 40 meters per second, so then the actual velocity of the object, if they are both moving in the same direction of the object, is 60 meters per second. So you have to be very careful. You have to define the reference frame from which you are measuring. Okay, and the problem is that there is a block, and this block is basically sitting on an inclined plane. So my plane, the angle might not be correct, but you can say that this is 30 degrees. Okay, and what I'm going to say is I'm going to use a block. Let's say there is a block here. Okay, and this block has some mass. Let's say the mass is m, and it is going to slide on this inclined plane. So, and it is doing that because there is gravity acting on this block. Okay, so that is the initial starting point. So let's say the starting point is somewhere here, so that is x equal to 0 position. Okay, and what the problem is saying that this block is sliding and there is no friction. Okay, so we will ignore the friction, so it is a much simpler problem. Okay, and now the question it is asking is, what is the acceleration of this object? Okay, and so that is the first thing you have to find, and the second thing you have to find is what is the velocity starting from rest, right, after it has moved a distance x0. So basically what we are saying is this object will slide and it will go to certain distance like here. Okay, and then this is the distance it has traveled. Okay, so I'm taking the leading point to the leading point, so that is my distance x equals to x0. Okay, and in this point basically I want to know what is the velocity at this location. Okay, so we can call it velocity v. Okay, and it is given that the initial velocity is 0. Okay, so these are the conditions that are given. Is you have to define, because this is a two-dimensional problem, you have to define what is your positive y and what is your positive x axis, That is what you need to define. So like we were discussing, first we have to take the object and we have to decompose the forces that are acting on this object. Okay, so because there is some angle theta here, this theta is basically 30 degrees. Okay, so from here basically what you can say is, first you have to figure out the relation and see that this angle will be theta, right? And how do you know that this angle is theta? Because if you draw a straight line from here to this point, right? So this is 90 angle, right? So this angle here is 90 minus theta, the one I'm drawing with the two lines. So if this is 90 minus theta, and this entire angle from all the way from this point till this point is 90, then this angle will be theta. Okay, so once you have reached that point and you have figured out that this angle is also theta, then you can use trigonometry and you can decompose the force that is acting on this object in the basically your x and y components. Okay, so first thing we get is sine theta is opposite side by hypotenuse. So you get that this force that is acting on this object in this direction is your fx sine theta, and because the only force that is acting on this object is your gravity that is acting here, so then we can write this as your mg times sine of theta. Okay, so that is what you will get in this direction. Okay, and remember we have specified that this is the y direction and this is the x direction. Okay, and there is another force that is acting along the negative y direction, and that basically is your mg cosine theta, which is this fx cos theta. Okay, so that is the force that is acting in this direction. Okay, so now what we do is, once you have decomposed and written all the forces, you have the object is sitting on this on this on this incline. So there will be a normal force that that with the incline will give on this object because of the contact, right? So any time two objects are in contact, there will be a normal force acting. Okay, so what do we do now? We'll use the second law, right? That is what we do. Okay, and the second law says that the net force is equal to m times a. Okay, so let's decompose this. Let's decompose the net force in the x direction. That will be the m times a in the x direction. Okay, so then now comes the part. So you have net force in the x direction. So one force is mg sine theta. So you write mg sine theta, right? Minus whatever is in the opposite direction. There is no force in the opposite direction. So that is the only force, and that is equal to m times a times x. Okay, so यहाँ पे तुम्हारा mm कॉमन है, वो कट जाएगा. So you get ax will be equal to g sine theta, right? And sine theta is sine 30, that is 1/2. So ax will become g/2, and that's how you got the first result of what the acceleration is. Okay, similarly you can say, let's see the net force in the y direction. So you get m a y. Okay, and now in the y direction you have n. So now look, n is in the same direction as the y, so we will have basically positive n. And now this mg cos theta is in the opposite direction to our sign convention, right? ये हमने कहा ये पॉजिटिव है, right? So अब हमको यहाँ पे क्या करना पड़ेगा, यहाँ में हमको माइनस एम जी cos theta लिखना पड़ेगा, right? Remember, net force is the sum of all forces, but we are not adding mg cos theta, right? Because it is in the opposite direction, we have to use a minus sign. Okay, so see, this sign convention will only come correct when you have defined what is the positive y and what is the positive x. Okay, and that should be equal to m a in the y direction, and this object is not moving in the y direction at all, it is just sliding along the x direction. So then this term is equal to 0. Okay, so then you get n is equal to mg cos of theta. Okay, so that is what you get, okay, from the second equation. All right, so that's good. Now how to solve for the velocity, right? So previously we had been given these equations. So if you look at the last equation, so the last equation is vxf square. Let's write that down. So you have vxf square is equal to what is it, vxi square plus you have your 2 times acceleration. So you have 2 times acceleration x and then you have your x of final minus x of initial. Okay, so that is your term for your equation. Okay, so basically if you use this equation, we are interested in finding the final velocity, right? So that is this term. We are trying to find the velocity at this location. So that is what we want. We have called it as v value, so that is v square. Initial velocity, we said that the object is starting from rest, so this value is 0, and then you get 2, and the acceleration in the x direction is g by 2, and x final minus x initial is the distance between these 2 points, which is defined as x of 0. Okay, so ये 2 और 2 cancel हो जाएगा, so then you get v square is equal to, or you can just write v is equal to square root of g times x0.